Hello everyone, Mansi here. So, proceeding with the last lecture, which was all about functions in C, now this is all about pointers and arrays in C. These are all the things we are going to learn in this lesson. Firstly, we are going to define pointers. Then we are going to classify the types of pointers and its subparts. Then we are going to introduce arrays, then types of arrays and its subparts. Then we'll be looking at the concepts of pointer to arrays and passing arrays to functions. So let's proceed. Now, what are pointers? We know that whenever we declare a variable and assign it a value, it is stored somewhere in memory with its own address, or we can say its own location. So a pointer is just an address of the data stored in memory, or we can say that a pointer in C language is a variable that stores or points the address of another variable. A pointer, it C is actually used to allocate memory dynamically, that is at runtime, and the pointer variable might be belonging to any of the data type like integer, float, character, double, short, etc., anything. And this here is the syntax for declaring a pointer. For example, let's declare a pointer. Let's say data type is integer and variable name is p. So we have declared integer space star p, where this data type is integer and variable name is p, and this star is actually a value at address operator, and it is used to get the value of the variable that the pointer is pointing to, and also to tell that this variable here, that let's say we have p, so this p is a pointer variable and not a normal variable. So there are actually two types of variable. One is normal variable and another one is pointer variable. So normal variable stores the value, whereas pointer variable stores the address of the variable. And as we are studying about pointers here, so we are defining a pointer variable, and if the star was not present here, so we would have called it a normal variable. So the content of the pointer should always be a whole number, that is address. Now C pointer is always initialized to null, that is the pointer we declared integer star p should be initialized with null, and the value of null pointer is 0. So the address is used to get the address of the variable, and this star is used to get the value of the variable that the pointer is pointing to, as I told before. So if a pointer is assigned to null, it means that it is pointing to nothing. So two pointers can be subtracted to know how many elements are available. But these two pointers, they are not allowed addition, multiplication and division. That is, pointer addition, multiplication and division is not allowed between pointers. And the size of any pointer is 2 bytes, and it is 16 bits for a compiler. For example, in this program, the output will be returned as 50. You may run it on your command line or whatever program you're using. So now let's classify the types of pointers. There are two types of pointers. One is pointer to pointer or the double pointer, and another one is function pointer. Firstly, the double pointer. When a pointer points to an address of another pointer, such pointers are known as pointer to pointer or double pointers. Its declaration needs two value at address operator as prefixes before the variable name. This here is the memory representation for the double pointer, which clearly depicts that pointer to is a pointer for variable I, as this pointer to contains the address of variable I here 1002 1002. Similarly, pointer 1 is a pointer for another pointer, pointer 2, because it contains the address of pointer 2 10001 and 10001. So that means that pointer 1 is a double pointer and pointer 2 is a simple pointer. Now moving on to function pointers. In C, it is also possible to define and use function pointers, that is, pointer variables which points to the functions directly. Function pointers can be declared, assigned values, and then can be used to access the functions they are pointing to. This here is a general representation or general syntax for declaring function pointer, which says you need to first specify the function's return type with the pointer name inside the parentheses and also the arguments which are passed in the function. For example, in this statement here, this statement, integer, pointer name is f2 and arguments are integer. So you can see we have declared this function pointer. You can match it with the syntax here. Here, integer is the return type of function. F2 is the pointer name and integer is the argument list for the function, which means the first argument for this function should be integer and the second one should also be of integer type. So I hope you probably have now received the basic idea about pointers. So let us move on to arrays. An array is a group or collection of same data types. But why arrays? Now consider a scenario where you have to store say 200 integer numbers entered by some user and you have to find the average out of them. Now to create such a big program, you have two ways. First way is either you define 200 variable of integer type and at last when you have defined all 200 variables, perform the average operation. Or second option can be to have a single integer array to store all the values. So which solution is better for you or according to you? Obviously the second one. Doesn't it sound feasible to you? Of course it does. And also it is convenient to store same data types in one single variable than to create hundreds of it. So an array is a collection of same data types which are accessed using a common name, and each value of an array is a member of that array, and each member in the array have a position which starts from 0. Now let's explore the types of arrays. There are two types of arrays present in C: one-dimensional arrays and multi-dimensional arrays. And multi-dimensional arrays consist different types of arrays like 2D arrays, 3D arrays or 4D arrays. Here we are only going to discuss about 1D arrays and 2D arrays. So just let's begin. One-dimensional array. One-dimensional array is like a list, or we can call it as a single line representation. Now consider this memory representation diagram below. Just ignore the values already present in this diagram. Let's take a fresh example. For example, let's say my name is Mansi. Okay, so counting the letters, my name consists of 5 letters. That means we have 5 elements: M, A, N, S, I, and they are all of type character. So how are these going to be stored in memory? So at address 100, M is stored. At 1002, A is stored. 1004, N, and so on. So this is how an element is stored when we are writing in a 1D array or whatever we insert, the string or the integers, anything. Now let's see how to declare an array in a program. An array can be declared with the help of the syntax here. You can see first you need to define the data type of the array as to what kind of elements are you going to store, and then the array name of your choice and the number of elements to be allowed for a particular array. Next, this syntax is for initialization and this here is for accessing elements of the array. Now you can access elements of an array by indices. Arrays have 0 as the first index and not 1. This is to be kept in mind, that arrays have 0 as the first index and not 1. If the size of an array is n, then to access the last element, n minus 1 index is used. That means if the size is n, then the last element would be n minus 1. Let's take an example for a clear perspective for this one. In this program, there are actually 2 ways shown to initialize an array, and you can choose either of them according to your convenience. I hope these comments here make the program clearer to understand. That means first we are declaring, okay, then we are initializing, and this is also an initializing method, and then this statement is for accessing the variable of the array. So in so try running this and you'll get the output something like value of array 0 is 10, value of array 1 is 20, and so on. Now, how to input data in arrays and how to read data from arrays, we'll continue from this in the next video.